Very good evening, everyone. Sir, am I audible now? So in this series of the AROHAN, I heartily welcome today's speaker, Chandra Kumar S, the senior software engineer from Pranavam Consultech Private Limited. So he is a promising professional with the passion of learning technologies and sharing the knowledge through technology trainings and workshops. He is experienced in the development of web applications, websites, and mobile applications, along with attractive UI UX designs. He is passionate in conducting the workshops on various technologies, in developing various webs and mobile application projects, handling internship sessions. He is a responsible full stack developer at Pranavam. So here I present today's speaker before you all. So now the session is open. You please can start it.
Thank you, sir. Good evening, everyone. So thank you for giving opportunity to proceed my experience, knowledge sharing, whatever the works I have done till now. Okay. Let me share my screen. I hope everyone able to see the screen, right?
Yes, sir.
Yeah.
Yes, sir. It's visible.
Yeah. So today we're going to discuss about Django framework. So what is the use and how it will going to where it will going to use and what are the use case of that, and so it will useful in the current trending in the web application, whatever the application we're going to build. So how useful that Django framework was. So right. So before proceeding with the Django application, I need to explain about what is the web technology, why I need to go with the Django, what is the Django framework, right? So now all of you can able to see the screen, right? So here you can able to say web technology. It could be any kind of applications like a mobile or a web application, anything right? So there could have the front end, back end, and server side programming, right? So you can able to, so in the majorly web applications, we having the n number of technologies and n number of tools, and we develop in a different variation of domains, right? So based on the use case, we're going to pick up which technology is familiar for, it will go which efficiently it will going to work with that, and so that way it will going to pick up. It doesn't mean this language is a good, this language is bad. No, nothing like that. So based on the use case, we're going to choose the technology. Based on that, we're going to work on the any technology will going to work. So same way, you can able to say, right, 5 different way we divided into the web application, whatever the application we're going to build. So we divided it into 5 parts: front end development, back end development, database, and DevOps, and mobile app with the development. So this is the complete flow. When it comes to front end development, right? So this is the one which, as a users, will going to access the system. For example, all of you have used last system command prompt oriented, like something like you need to give a commands. Based on the command, it will going to give. So that some knowledgeable person can able to access, and based on that they can interact with the systems and the user. So but it will be non-technical persons, those are, it will difficult for them to access and get the details. So that's the reason. So we're going to build a UI for that. So interaction, already you people have used many applications like Flipkart or ARTCC, booking the platform on Flipkart for booking, purchasing the many application, something like that. So there you can able to see the product details with the image and the detailed description about the details, And also you need to interact with the application. You having the n number of buttons, so that you people already use the system. You people already knew, right? So the button symbol, it will tell like, so if I click on that, something will going to happen. So something like that. So we need to divide. We need to design a UI. So that is a more important, like transaction between the application and the user. So that's the part we're going to design in the front end development. So here just I mentioned JavaScript and HTML, CSS, and also some frameworks we could build using that. Like currently we having multiple frameworks, which libraries which give a n number of pre-built designs. So no need to build any application, like whatever the application we're going to build as a new system. You don't need to scratch. You need to build that. We having n number of libraries which is already built by most of the top companies like Flipkart, like Facebook, Meta, like and Google's. They already use cases, that the same use cases they built the some of the applications. So they build the libraries they given for open source. So we can use that one as a open source, as a no need to pay for anything. Just use the library. We can same application. You no need to scratch. You need to build. So just use the methods and whatever the configuration we need. Just import it, and we will going to use that. So same way, we can design like as an example, I can tell like Bootstrap, Tailwind. These are the major libraries which designing the web application. It will give a number of value to the UI, so attractive to the user to interact with that. And the same way, backend functionality. Backend is the one which is programmatic. Will go into what the things should happen. So as a front-end development, it is just a interactive things and attractive the person and the transaction we're going to do. But the backend is the actual one, which is the system. Like we having n number of plan environment. Like Windows system is the one of the OS platform. Unix is the one of the um, OS platform, like that Unix and Mac. So we having a number of different software, like OS is there. So whatever the application we need to build, right? So that should support for every whichever the user having the accessible device, it should they can access through that applications. So that's the reason, like we need to whatever the language we are going to pick, right? So that should support for all the environment, whichever the device we are accessing. It should have accessible way. Every users will going to access, like who is the needy, right? So that way. So now we already you people have learned, right, to C++. So these are the major first level, like languages which what is the programming, like how it will be. So that is the basic idea it will give. It will going to give. So same way, like now currently, so majorly multiple applications we build using like Python, .NET, C Sharp, like same thing, like Python oriented. We having multiple frameworks, and in web development only we having the PHP. Same thing like Java. So we can switch any server side languages to build. So majorly part of like connecting between the storage and the what logic, like what are the things, what are the transaction we need to do. So that we're going to mention in the backend functionality. So same way, database is the one currently. So whatever the transaction, like whatever the as a user, as a system communicating, right? So somewhere we need to store that. Without storage, without the container link, we can't accessible. So for example, so in a Facebook or somewhere, you already seen, right? You need to upload. You're going to, as a local system in your mobile, as a local storage, you store that. But when you upload to the cloud or somewhere, it will go to store in the server. So somewhere you need to store. So whenever you are the person, you as a current accessible person, so you need to visible for the all the will going to see the system. So that I need to get it from. I can't get it from the your local system, like who is accessing the local. So anytime it's going to off or on. So sometimes I need to access that. So that time 24 bar it should be accessible. The server should run. So it can't possible, right? So that's the reason we build a cloud or a server environment. So there we maintain a structure way. So how it will going to store. So we maintain that data. So whatever the images, it could be any data. So anything it will be. So DevOps is the concept like, so whatever the application we build, right? So that maintenance we're going to do through DevOps. For example, uh, so single application entirely as a single person can't build, right? So we having multiple n number of teams and n number of persons who handle with that and application, and parallelly they're going to develop the applications. So that time what we need, like whatever the we need to merge, right? So 10 different people worked on the 10 different features. So finally, as an application, I need to merge everything, right? So merge it, and the merge it, whatever the merge application is there, right? So that I need to set up in the environment. That could be every time we should um, reflect in the environment. So that is the many things will be there that we can cover in the next session. So this is the main management, like whatever the development application will do, right? So that will going to through DevOps. We are having multiple divisions in that. So based on that, we're going to manage multiple way in that, like scaling the application. For example, we build the application. We're going to access millions of peoples. So server, if you're having the minimal server like 2 GB of RAM and so minimal configuration setup device means, so that number of uh, millions of people, it can't handle the application. So that time, so I need to scale the applications. So how many millions of people access also, I need to scale the application to freely accessible to the system. Like that, we having many things in DevOps concept. So same way, mobile apps. So so whatever the web application we build, right? So entirely we can use through mobile also, like through mobile app or web app, like we having the mobile also including web app, we can concat that. It doesn't mean we need to build everything in the mobile app. So some of the part of code, so everything will be changed in the day-to-day life. Something like news or some features. So if you install the application, every time we can't ask the user to, every time you need to update the system, you need to update the application, something like that. So it once the user is installed the system, we need to give a provision to whatever the system changes, whatever the feature changes we made. So that should reflect in the instantly without upgrading the application also. So that way we can through a web application we can do, and so like that we having many feature using that. I hope yeah, people are clear, right? So this is how the things will divided on, as is every application we divided into this many parts in that. So in that every parts we having n number of features, like n number of languages, n number of libraries, many things will be there. So that will cover up in the next class, like we'll see that. So as an application I told, right, every application will having the front end, back end and database. This is the overall application structure will look like. As a front end, I already told. So as a user, we're going to interact with the application. So that oriented designs and that relevant technology will use for develop that part. And the same way, backend functionality one is a server-side programming. It is the actual one with connectivity within the storage and along with the servers, and what action we need to pass to the user and what action I need to do as a calculation or anything I need to perform. So I will going to do with the backend functionality. We having a number of server-side programming through that. So this is the overall application, the behind. So all are people who are going to develop. So who are like as a front end, back end database, we having multiple teams. That it doesn't mean is a full stack. If people I can see, right, full stack is the one will going to handle the entire thing as a front end development. It could be back end or a database oriented, anything. It'll going to handle by every three modules here. But in the platform, so entire things we can't give to as a single person here. So we're going to divide into everything in a different section and different team members. So that way we can manage, and also we can build the application in an easy manner, and also fastly we can deliver to the client. So that way we'll divide into front-end developer and back-end developer and database structuring and architect team and the maintenance team. So something like we're going to divide. So same way, full stack is the one we're going to handle everything here. So this is how the overall picture of web development. So what is the use of Django here? So it's the high-level Python framework, like it's an open source, which is we're going to build. So some in the system we can able to see, right? In HTML, CSS, JavaScript. So these are the different technologies we need to maintain in a different like a structural format. Otherwise, what will happen? As a jar, I can put like stone and marbles like sand, everything in a single jar means I can't so some what will happen? I can't only I need to take the sand means it will difficult for me to. So managing the things and using the and debugging, so it will difficult for me to do managing things. As a Django framework, what will do? It will give a predefined structure for it. So predefined structure in the sense, as a front-end development, what are the files you're going to have? So that you need to maintain in the separate folders. So same way, what are the accessing database, controlling the codings, so that we're going to maintain in a separate files. So same way, like as a database, we're going to separate files we're going to maintain. So that way we're going to predefined structure it will going to give as a Python as a Django framework. So that what it will use for example, whatever the application we're going to build, right? So whatever the issues or whatever the design I'm going to do, it will could have the structural way. I can easily track the files and directly I can access that and I can easily build the applications. So that usefulness it will give with the Django applications. And also predefined like authentications and security purpose, and also some of the Python language could give some AI ML models. So no need to different platform like some application is going to be built with PHP. So you need to integrate with any machine learning oriented, any data science operations you need to perform. So that time what will happen? So you need to different platform here, like PHP is a separate platform and Python is a different platform. Integration like connecting between the two different is a different effect. But if you choose with a Django, it will support both, like is a model relevant, anything like is a Python language. So it support any kind of like model oriented, data science oriented, and any AI models. And there are many software companies supporting this language, and also it is a open source and easy to learn. So that's the reason Django is a more familiar. So nowadays, like many applications we're going to build with this one. And also, I'll explain like project architecture in the sense like you can able to see three different roles, right? Controller, model, and view. So these are the predefined structure I told. Like controller is in the sense which is we're going to handle so connectivity between the database and the what are the operations I need to perform. So that whatever the script I need to write, so that Python script I'm going to write in the controller. So which page, what data I need to pass, something like that I'm going to do in the controller. Same way in the model is the one which is a database, which having the query kind of link. For example, model I'm going to build as a model as an employee. Whatever the employee details I need to fetch, I'm going to mention what are the fields comes in the name or phone number, age. So anything I'm going to mention in the models. Through that, I'm going to access the data. Same way, view is the file structure which having the all the UI oriented, like what are the details I need to visible through application, what page I need to visible. So that all I'm going to mention in the view controller. So this is how the project structure will be. So this is how the transaction will happen. So the Django usually use the pattern of like architecture like MVT. So model in the sense like it is a database, like storage relevant you're going to mention in that. View is the one user going to accessible designs, whatever the things I'm going to mention, right? That I'm going to design in the view part. Under the views, we're having the templates. There we're going to mention all the HTML files which we designed that. So this is how like through template, I'm going to get the details from the view. I'm going to call the user controller. So this is the data I need. So that data I'm going to through control views. I'm going to get it from the model. So this is the cycle of data I'm going to transaction through the application. User going to request that in the controller will go and mention what data I need to pass. Same way that data will going to get from the models. So this is how the flow will goes. So same like in a easy manner, you can tell like user going to access the Django application through views. I'll go to connectivity like which page I need to render and what data I need to take it from that. So that all will mention in the, this is the transaction way the application will work. I hope like it's not much details that, but try to understand this is how the structure will work and also predefine what are the features we're going to use in that. And also this application, like this framework we're going to choose, right? It could also having the some of the blocker, like whatever the some features, like it is a easy language we can easily build, and we need to pick as a big application, like whatever the we're going to this environment we're going to set up, right? It need more number of manageable software environment to manage. So you need to pick simple application. You need to manage more cost means it will difficult. Try to pick this Django framework, which is having the more features with more how much standard in that. So that way you need to pick. ORM is the concept. No need to like if you are switching back to Django application, you no need to learn any query kind of thing like the select query, insert query, MySQL queries you need to learn, right? So that predefined structure way, so they given a ORM model. So you don't need to learn any query kind of things. Just you need to learn the multiple methods. For example, you need to get the query data from the select using employee details. You need to write a query like select star from employee kind of query you need to write. When it comes to ORM, you need to mention the model name. Just you need to call the method name called all. So it will get all the details from that. So these are the some features which will predefine the Django framework is giving. So we need to make use of that, and it will easy and also more secure compared to SQL injection. Many problem here multiple applications are facing. So that it will be easily trackable and easily we can solve by using ORM. So the same like easy database management, and also be having more security compared to any other languages. Like cons is is a small project, minimal project. We need to environment setup with a huge cost. So don't pick that minimal project with a static website. Right? So try to pick up any dynamic website. It will learn more feature oriented. So whatever the transaction relevant to application we need to build. So try to pick these languages. And also monolithic, we having currently whatever the application we building, right? We having a two different way we can build monolithic and microservices. Microservices means like a single application will divide into multiple parts. So we'll go into communication, we will going to bridge will going to build through that it will go to access. So monolithic in the sense like everything as a single landed, everything will be present in a single app. So easily manageable and also completely single application is one. So this is how the overall Django will work, and these are the many features, and we having that. So we need to choose in the such a way that so based on the scenarios and use case, we need to switch it to this application. If you're having any doubts and any clarification, just let me ask with. You can proceed and can.
Yes, sir. Yes, sir. Thank you very much, sir. It was indeed a wonderful session. I think some of the participants had already raised their hand. Harshita, if there are any queries, the participants can raise the hand and we'll unmute the mic and they can ask the query to the speaker.
Anything else?
Was
most of the things I just covered, but it's not in detail. But maximum how much I need to cover, I has covered it. Still, you need any suggestion, like any doubts, what need to like you need to learn, where you need to explore. Just let me know. I'll explain, and what are the links you need. Just I'll explain those things.
If there are any queries, you can raise your hand now, and the speaker would be very happy to clarify your doubt. If you don't have any queries, so we are going to end this session. Participants, do you have any queries? Okay. If there are no queries, then we will move on to the next session. Before moving to that, thank you, sir. Thank you, Chandrakumar, sir. It was indeed a wonderful presentation. And I think most of the fraternity of faculties and as well as the students have benefited with this particular presentation, especially to the circuit branches.
Yes, sir. Thank you, sir. Thank you, team.
Thank you.
Team members. Yeah.
So I will now request the next presenter, Dr. Suresh sir. Here is the brief introduction of the speaker. Dr. Suresh K is the assistant professor in the Department of Mechanical Engineering, Government Engineering College, Talkal. He has his PhD from Indian Institute of Technology, Madras, in the year 2020. He had his post-graduations in BDT, Davangere. He had his undergraduate at the Ballari Institute of Technology, Ballari. He has 13 years of teaching experience. Formerly, he was serving as the assistant professor in the Government Engineering College, Hoinhadagli. Currently, he is at GEC Talkal. Yeah. Apart from his teaching experience, he also has served as assistant manager in the Department of Engineering Services, Jindal Steel Limited, Ballari. So this is the brief introduction of the speaker. Sir, now the room is open to you. You please can start your presentation. Suresh sir? Sir, you are not audible.
Suresh sir, if you are hearing us, there is a small icon on the right hand side of your screen. It will go to full screen mode, or you can press F5. Suresh sir? Sir, you please unmute yourself, sir. Suresh sir, you have to unmute. Sir, I think your presentation has to be unmuted. Suresh sir? Sir, yes, sir. Now we are able to hear
Probably
you.
problem with the mic, sir. So I will go ahead with the laptop. Okay, sir. Audio.
Yeah, please put it onto the full screen mode, sir. Your
Yes, sir.
slides,
Yes, sir.
if you-
Yes, sir. Thank you, sir.
Thank you, sir. Thank you.
Sir, I hope my voice is audible to all of you. So I'll continue with my
Your voice
presentation.
is audible, sir. Your voice is audible, sir. But your presentation is not in full screen mode.
Okay, sir. Now, sir, is it full screen, sir?
No, sir.
Not yet.
Slideshow mode. You can put it to slideshow mode, sir.
Yes, sir.
Yeah.
In fact, I have put that in the slideshow mode.
F5.
Is it changing, sir?
Have
Now
you-
slides are changing.
Sir, have you shared the full screen, sir? Full screen, entire screen, have you shared?
Yes, sir. I have done my PPT with the full screen.
No, not to PPT, sir. While sharing onto the meeting platform in Google, have you shared it full screen? Have you taken while selecting it?
Window I have taken, sir. Sharing window.
Yeah, in that you take entire screen option, sir. Then your screen will come with.
1 minute, sir. Yeah, 1 second.
Yeah, please.
So now is it okay, sir?
Sir, we are able to see your this thing, sir, computer inside, but not the presentation. If you open the presentation, sir, we'll come to know.
Yeah, now actually I opened my presentation.
No, we are not able to see. We are seeing your local disk E here, sir. That is displayed.
1 second, sir. That is with the entire screen. Now, sir, is it okay, sir?
Yes, sir. Yes, sir. Please go ahead, sir.
Okay, sir. Thank you so much, sir. Thank you for the opportunity, sir. My name is Dr. Suresh K, working as assistant professor in the Department of Mechanical Engineering, Government Engineering College, Karnataka. I am presenting a session in the AROHAN GEC Best Practices, Lecture Series 9. My topic is from past to present, transformative shifts and future imperatives in mechanical engineering. So I have prepared these contents. So these contents are prepared based on my exposure and interaction with the eminent personalities in the field of mechanical engineering. So the contents are introduction, mechanical engineering stream tree diagram. Next is the scope of different streams, an example I am producing. Next, mechanical engineering scope in the different industries. Next, key statements which I have taken are interacted with the eminent personalities. Just I have put in this slides. So next, paradigm shift from past to present. So next is the future of mechanical engineering trends to watch in 2024. How mechanical engineering can prepare for the future. So some key competencies students should have. Next, a pathway to mastering advanced learning methods. So finally, it is conclusion. So introduction. So these are all the things just I am repeating those things. Over the years, mechanical engineers have learned all kinds of groundbreaking inventions from steam engines to steam boilers to spacecraft. Mechanical engineering involves designing, building, testing, and improving mechanical devices and systems. As our world keeps changing, new technologies that reshape the future of mechanical engineering, such as artificial intelligence, advanced robotics, 3D printing, sustainable design are just some of the big trends influencing the field today. So next is mechanical engineering streams, tree diagram. Yeah, this is traditionally, everybody knows this. Machine design, what all the subjects aspirants learn in the UG course, that is basic mechanics. So next is rigid body mechanics, next deformable body mechanics, and such related subject, finite element methods, mechanical operations. In the thermal engineering, yeah, go with the basic thermodynamics, thermodynamics, fluid mechanics, heat and mass transfer, turbo machines, fluid power engineering, refrigeration, and air conditioning, and similar subjects. In the manufacturing engineering, yeah, it's computer-aided drawing, of course, every stream will study this. And metal cutting and carving, metal casting, welding, mechanical measurements, metrology, and non-traditional machinings, computer integrated manufacturing, and so many similar subjects. Coming to an example, so the role of different that is stream engineers, what is the individual role they play? Let me take an example: preparation of pellets to feed the blast furnace to produce pig iron. This is related to the steel plant. So where this left bottom corner, you can see the pellets which are fed into the blast furnace to produce a pig iron. How these pellets are prepared? These are in the shape of marbles, that is spheres. So there is a disc you can see here. It is not in something centimeters. They are meters, like now size. You can imagine that is double-story building. So that is maybe the 7 to 8 meters diameter. So this has been rotated. So this over which the metals are fed with additives, so that while rotating, so the mud takes the form of sphere. Yeah. So at the back you can see there are motors, gearboxes, okay, bearings, shafts, so many such kind of structures. So after forming in the spherical shapes, they have to be strengthened to remain in that shape. That's why they have fed through the conveyors over the heating chamber. So once it has been passed through the heating chamber, yeah, finally pellets are prepared. So here the role of, I want to highlight here the role of different stream engineers, that is design engineers, thermal engineers, and what is the role of this manufacturing engineers. Design engineers, what they do is prepare the process design, size of the equipment. You see this, for the given production rate, the size of the disc has to be finalized. So, and size of the structure, supporting structure, okay, and motors, everything, okay, they design, and finally they produce in the form of, that is, drawings. Yeah, you see this again here, there is a temperature to be maintained in the chamber. Thermal engineers, so they will find out what is the temperature to be maintained or controlled, so that the pellets will will be strengthened and to remain in the same shape. So manufacturing engineers, yeah, there are so many structures here. So designers, they give the drawings to the manufacturing engineers. They fabricate the drawings in the form of, okay, as per the drawings, they fabricate the equipments or machines. I'll take another example. It is also related to the steel industry. So here, billets. So these are all very, very large length, that is sized steel billets, which are cross sections, maybe around ranging from 100 mm to the 200 mm, that is per section. So here, the molten metal from the ladle is fed through something like a chamber, that is water-cooled mold. So further, it has to be taken as a solid shaped billet. So the liquid metal has to transform into a solid metal by passing through this water-cooled mold. So here you can see water is circulated around this mold. So what is the that is quantity of water or discharge of water to be maintained, so that the liquid metal is converted into solid with temperature maintaining to some extent, so that even it can further bend and pass through these rollers. So here there's a lot to do with the, again, design engineers. They design the all these structures, rollers. You can see there are so many mechanisms, gearboxes, rollers. All these things are designed by the design engineers. Thermal engineers, there is a lot of scope here. They need to find out the level of water to be supplied so that it remains in the solid state with some temperature. Again, manufacturing engineers, they fabricate the drawings as per the recommendations are prepared by the design engineers. So similarly, so there is a lot of scope for the mechanical engineers. The major industries such as automotive, aerospace, defense, steel, power, locomotives, earth movers, shipbuilding. Next to oil and petrochemical industries, cement industries. Similarly, there are so many, even small scale industries. Of course, they have the scope for the higher studies also. So there are, with my exposure, and I have collected some statistics. So the per capita steel consumption, means per person, what is the steel consumption per year? So in the whole world, it is 233 kg per year. In India, it is around 77.2 kg, gone up by 50% in the last 8 years, which is 1/3 of average world per capita steel consumption. So there is a lot of scope, for the development in India, because still the level of life, it is in below average. So if at all the life to be improved, so how they measure, the country's well-beingness by the different factors such as steel consumption, coal consumption, and power consumption. There are similar factors. So the development of that is country is measured. So under that, steel is one. So there is a lot of scope for the India, of course, to develop further. So because consumption of steel is bit less compared to the whole world. Again, coal consumption. Coal is used in several sectors for the power and for the like even steel sectors. So in India, it is 1 billion tons per year it is consumed as of now. In China, it is 5 billion tons. So again, size of the machines. So few decades back, the size of the machines were medium scale, but now it is from micro level to the very large scale. So this has been said by this Professor Kincher, who is the ex-vice chancellor of VTU. Engineering nowadays becoming unified. So means not only a machine. Earlier, it used to be with the mechanisms, both from the input side as well as the output side. But now, no, actually electronics and computers. So they embedded with the machines for the improved performance and efficiency. So that's why, so engineering is now becoming unified. So this has been discussed, said by Dr. Mohan, who is a professor in the Department of Mechanical Engineering at Karnataka. So with these statements, I have prepared some more slides. So I'm just going through this. Yeah, you see this. This is a UTM. Yeah, most of the mechanical, every mechanical and civil engineers, well aware of this UTM. So right side part is now, earlier it was with the dial gauge, that readings, load or even deflections. And graph is usually you see this, pencil with some paper. So this right side part is dial means, behind that there will be something like gears and linkages to operate this. Is that right? So, but now this part is outdated. So in the right side, you can see is occupied by now computer and electronics, digital display and data acquisition systems and storage of results. We'll get the printout, or even data from the computer itself. So again, if you see this size of the computer, in 1960s, in the beginning, that is development of the computers. So very large. Nowadays, it is Everybody knows this, the laptop and the desktop. So again, so you see this, earlier the drawings were prepared, okay, with by using, what is this, the board, drawing board, T-square and tri-square manually, even assembly drawings or detailed drawings. Now, of course, with the help of computers and computer-aided engineering drawing tools such as AutoCAD, okay, next even 3D modeling softwares, CATIA, and some more. Okay, so we are going to prepare now with the computers, and of course, we are going to take different sized, okay, drawing, that is, even it may be A0, A1, A2 sized, okay, printouts with the printers. So yes, now I want to just justify that here consumption of steel. Okay, so earlier buildings, it is a small examples I'm giving. Okay, a few decades back, from 30, 40 years back, buildings were built usually with what? So directly raw materials such as rocks, okay, timber, okay, mud, okay, such kind of things. Now, so middle class and above, you can see in almost all areas. So they have the buildings with tons of steels, cement. So that is converted products. So again, they are using car. So everybody now we are having, okay, two-wheelers cars. So steel consumption, it is now, okay, earlier it was very, very low, few decades back. Now it is, okay, multiplied. So, but as we noted earlier, the per capita consumption of steel, okay, it is 77 kg. Okay, of course, it has grown up 50% in the last years, but all over the world, it is 233. So there is a lot of scope, okay, further to develop infrastructure. It is not only domestic applications, that per capita income. So commercial applications also it includes, okay, bridges, buildings, okay, even road constructions. So yes, further, yeah, size of the machines, it is micro to large. So a few decades back, the size of the machines were not such big. Now you can see this, there are so many earth movers, very large in size. So these are the machines which are used in mining areas and tunnel drilling. Okay, you see this rails. Nowadays, no, there are so many places where the, okay, metros, for the purpose of metros, tunnels are drilled. So these are the very large machines. And of course, wind turbines. There are so many similar, okay, machines which are, okay, very, very large. And next slide, I'll show you that size of the machines also in the MEMS. That is from ranging from 100 nanometer to the 1 millimeter. So these MEMS devices are used in automotive, medical, electronic, communication, semiconductor, defense, aerospace, and more. The preparation of these micro electromechanical systems includes photolithography, ion beam etching, chemical etching, wafer bonding. So I will show some of the applications of these MEMS devices, that is inkjet printer heads. Next, MEMS devices include accelerometer for airbag sensors. So these are the some dark, okay, patches you can see on the car, that is picture. So when there is a change in the acceleration, maybe due to the that is accident or similar things. So this change in acceleration, okay, which gives rise to a small change in the voltage. In turn, they will actuate the, that is, bags. So for the safety. So these are all very, very small devices. So computer disk drive heads, again, yeah, blood pressure monitoring sensors. So a small sensor is embedded in the, that is, wrist belt. So it can continuously monitor the blood pressure. Similarly, biosensors, they are in the size of 50 nanometers. Again, similar MEMS switches extensively used in the circuit, okay, devices, measurement, resource sharing, line protection, remote network monitoring, bypass switching. So the future of mechanical engineering trends to watch in 2024. So artificial intelligence, yeah, everybody knows that the changes which are happening due to artificial intelligence. So this scope, that is artificial intelligence, yeah, even you can include in the mechanical systems. AI making its way into all kinds of machines and mechanical systems these days. For example, AI powers the computer vision that lets self-driving cars see traffic lights and pedestrians. So AI guides autonomous robots to optimize production. So there are so many things to explore with the help of this AI, artificial intelligence in the field of mechanical engineering for efficient operation. Further advanced robotics, it is not so easy to work in the environments such as hazardous environment in the steel plant. No, there are so many places this dangerous gas, that is carbon CO monoxide. So there, no, yeah, there are a lot of fatals which are happening. So those can be avoided by using these robots, even in the very high heat zone affected areas. So there is a lot of possibilities to explore the usage of these robots in the field of mechanical engineering. Next, 3D printing. So traditional printing, that is machine manufacturing technologies. So we have varieties of machines, farming operations. So those are all maybe in the upcoming years maybe outdated. Okay, with the 3D printing, because no, this 3D printing can uh, produce intricate shapes, very large parts, with the simple production technology. So this 3D printing is used in the aerospace, automotive, and medical films. Okay, now use 3D printing for end-use components. So of course, in the previous AROHAN, that is lecture, I heard that one professor given a session on the topic that is Prakriti Purusha, Engineering and Sustainability. So I am really impressed with that presentation. So he said that the nowadays this engineering what we are going ahead. So it is distracted to the ecosystem. So we should preserve this ecosystem by changing our technologies. So by improving solar panels, advancing wind turbines, turbine designs, building utility scale batteries, transitioning to electric vehicles, all are areas which one can focus. So mechanical engineers will keep pioneering innovations like high efficiency solar cells, floating wind farms, and smart power grids to enable the widespread adoption of clean power. Yeah, some more areas are smart, efficient, sustainable HVAC systems, heating, ventilation, and air conditioning systems keep building comfortable and air healthy to breathe. Okay, so these are the areas mechanical engineers can explore further, and electrical vehicles which are eco-friendly. So of course, this electricity production, in India it is by most of the plants use the coal. But now, of course, one area we are making very high pollution, but now we are saying that electrical vehicles in the cities. But other area where the coal is burnt for the power, so that area it is highly polluted. So instead of now, power developed by the that is thermal power plants by using coal, we need to go for the renewable source of energy such as solar and wind turbines. So next, the future of mechanical engineering, that is how these trends will shape the mechanical for mechanical engineers. These technologies will produce new products and services, and faster, cheaper, and more efficient design and manufacturing, build a safer, healthier, and more sustainable world. So to achieve that, UG completed students, what he should have, competencies. So as we noted that, interdisciplinary subjects we need to learn, not only the core subjects. So again, learning programming, electronic and mechatronics to interface with the smart systems, developing strong conceptual foundations in maths, physics, mechanics, thermodynamics, and manufacturing. Of course, one should have a fundamental knowledge of the core subjects. Later, no, again, we need to have a interdisciplinary exposure to the interdisciplinary subjects, and apart from that, yeah, learning programming. So yes, I will now go for what is the methodology that we are having in our academic systems. In fact, I am dealing with these things, okay, in my classroom. So typical questions in examination for the students. You see, this is a small example. So every mechanical professor knows about these things. Yeah, you see this, VTU has asked this question in 2002, again 2016. There's so many times. Yeah, fine. This is, of course, core subject. So that is machine design. Student must learn. But thing is that, yeah, here, question paper, what they ask is from past 20, 30 years. Same questions are there. But the thing is that what is the change that student should now have? As we know earlier, so student will be exposed to programming and interdisciplinary subjects. So now somewhere this gap is need to be filled. So again, what I noticed in the students is that, so just while interacting with the students, so you see this, there is a step with the fillet. If I change the radius of the fillet, so students need to analyze what happens to the stress, okay, at this edge, whether it is going to reduce or increase, how it is going to increase or reduce, whether linearly or any other kind of nature. So these kind of analysis discussions students should have. Okay, I will take you to the next slide. So that is typical questions. Again, we will have something like formulas to find out the displacement of a piston by using formulas. With the given data, there will be some unknowns where students use some formula or the data handbook. They will take some data and find. This is typical. It is going from past few 2 to 3 decades. So, but thing is that, yeah, question paper or textbooks, it is same. But thing is that now analytical skills, analysis, ability of the students, or discussion ability of the students. What is the question? There is a big question mark over there. So if there's small change in the displacement or angle of rotation, what happens to the displacement? What is its nature? So that they are unable to express. So if they give data, they are able to take a formula and find the unknown. But thing is that if I change a small angle, what happens to the displacement? So means here we need to ask the students or in the form of assignments or questions, so that how this x displacement is going to change by changing that is the angle of rotation. So they need to go for something like coding that is maybe that is online available with the Scilab or MATLAB. So this thing I noted that we need to concentrate. Okay. Similarly, similar questions in the material science, that is a steel body component which has to be hardened by giving a carburization process. The carbon atoms, okay, on the surface of the steel, that is diffusion process. Okay, so here again, there will be a set of formulas, there will be some unknowns, there will be some given data. Student will find out some unknowns by using the formula. But what happens with that is depth of penetration of the carbon atoms with respect to the time or with respect to the temperature. So now the discussion comes. So there they are failing. Why I am stressing here is that because in a few months back, in our college, nearby our Westpet Steel company, they have came for replacement. And there's almost some 30 plus students are appeared for the placement. Out of 30 plus, only 2 have been selected. They said that they require another 2 or more, but no, students are not able to answer the questions. Why? Because the given feedback given by them is that students should express that what is the that is nature or no. Speaking ability, communication skills. So that somewhere it is missing out. So again, similarly, if I take something like some other equations, we need to ask the students, okay, the nature of graph, how it comes by asking them to go ahead with the with the programming. So yeah, these are the things that I have prepared. Yeah, the field of mechanical engineering. Yeah, I come for the conclusion. The field of mechanical engineering is full of opportunities for those who are creative, innovative, and have strong problem skills. Along with the core subjects, learners should study interdisciplinary subjects such as signal processing, artificial intelligence, and machine learning tools. So yeah, so I conclude my session here. So if anybody having questions or suggestions, and yeah, this is now open because these are the slides prepared which are roughly based on some statements or with my exposure or interactions. So if anybody wants to ask some questions or give suggestions for the improvement, please let me know.
Thank you, Professor Suresh. I think the audience, if you have any questions, please do raise your hands. We can unmute it. I suggested if you have some suggestion, you can put in the chat box also. So I think there is no questions.
Okay, sir.
Yeah, thank you, sir. It was indeed a very excellent presentation, and it was the need of the hour because many of them are thinking that the core branches are getting totally neglected, and this was insight. Even being with the core branch, we also learned so many things from your presentation. Thank you very much. Now
Thank
we
you,
have.
sir. Thank you for giving an opportunity. I thank Yugar sir. I thank Professor Basura sir, Vivek sir, and thank DT and Commissioner Office. Thank you, one and all, sir.
Thank you, sir. Thank you. Now we move on to the next session speaker, Professor Pavitra T, who is an assistant professor, Group A, from Department of Electronics Communication Engineering, Government Engineering College, Kushalnagar. She is pursuing her research on security aspects of vehicular ad hoc network using machine learning. She has got a teaching experience for a decade in engineering colleges, and she's teaching specializations in machine learning with Python, C programming, and embedded systems. With this brief introduction, I welcome you, madam, to today's session. The floor is open. You can share your screen and start your presentation.
Thank you very much, Kiran sir. Just wanted to know if I'm audible and the screen is visible.
Yes, ma'am. It is very, you're audible, but the screen is visible, but it's not in the slideshow.
Okay.
Yeah, now it is. Yes,
okay.
ma'am. Thank you. Thank you.
Yeah. Good evening, everyone. My introduction, Kiran sir has already given, so directly I'll start with the presentation today. Today I'll briefly go with the presentation on the future of transportation, that is nothing but vehicular ad hoc networks. It is even called as VANETs. So when it comes to VANETs, in this session, we are going to cover briefly what is a VANET and mainly concentrating on the applications and the research opportunities. This will be the flow during the session. Initially, we will study what exactly are VANETs, and we will study some of the key characteristics of VANETs. Then we will move on to the application areas of the VANETs that will tell us why the VANETs are necessary and what is the implementation status of VANETs in different countries. Then we will look into the research opportunities that are available in VANETs. And finally, we will conclude with a brief summary of the session. So what exactly are VANETs, or what VANETs exactly consists of? So VANETs are nothing but a network which is formed with the help of mobile or immobile vehicles that we can see in the picture over here, along with some fixed infrastructure along the roadside. So the combination of these vehicles along with the fixed infrastructure is generally termed as basically as a VANET. Apart from this, depending upon the application, we may need some extra infrastructure also that we will discuss during the applications. So here basically we have only two components. One is vehicle and other is the roadside unit. This is the fixed infrastructure, briefly called as RSU. Now, since the vehicles are the major part of the VANETs, which most of the time are mobile, and these vehicles will be moving, it is not possible for us to provide a fixed network. That is, we have to provide a temporary network for these vehicles to be connected to the RSU. That is why we will say that these VANETs can also be considered as a type of mobile ad hoc networks. Mobile due to their mobility, and ad hoc because they will not have a permanent infrastructure for a networking. And as I said, the basic components of VANETs are the nodes and RSU, that is vehicles and the roadside unit. These vehicles are even called as the nodes. For these vehicles to be a part of VANETs, we will require certain hardware. Then only they can contribute or they can be a part of our vehicular ad hoc networks. So what exactly that hardware we are going to use along with the vehicles? So in the vehicles, we will be making use of a hardware called as onboard unit, which is in short called as OBU. So that onboard unit is capable of transmitting the data, it is capable of receiving the data, and it will also have a global positioning system, that is GPS, and it will have a processor which is capable of processing the data. So basically, if it has these minimum 4 components, then only an OBU can be built. And if a vehicle is equipped with such OBU, then it is considered as a node. If there is no OBU, we cannot consider that vehicle as a node in case of our VANETs. And apart from that, the second component is RSU, that is roadside unit. So roadside units, they have an internet connectivity, which are again connected to another centralized system, which basically help these RSUs to get the internet facility. And these RSUs can provide that internet facility to the vehicle users. Therefore, basically, users need not to make use of the traditional mobile data, whatever we are using nowadays in our vehicles. So instead of that, if we can get connected to the RSU, from RSU, we can receive the internet facility. So whenever we talk about a particular network transmitting or receiving the data, we know that certain standard has to be developed, somewhat similar to our cell phones. When we talk about cell phones, we will specify what is the frequency range, what is the transmitting power it has to use. There is a standardization for everything, right? Similarly, in case of VANETs also, some standard has been developed that states what is the frequency that we have to use, what is the transmitting power, and then what are the various rules that we have to follow if we want to be VANETs. So in order to specify these standards, we are making use of DSRC protocol, which is DSRC standard, which is nothing but dedicated short range communication standard. Under this dedicated short range communication standard only, our VANET is going to operate. Under this standard, the frequency that we are going to use is between 5.85 gigahertz up to 5.925 gigahertz, which is centered at a frequency of 5.9 gigahertz. So totally between 5.85 to 5.925, that will come around 75 megahertz of band. So as we can see, 75 megahertz of band is a very smaller band that we are going to get in order to use our VANETs. But within this band only, we are going to consider the transmission and reception of data. Again, that band is divided into number of channels as service channel and the control channel, depending upon whether we are trying to send some data for disseminating some information, or is it some control channel that we are using in our, for some security purpose or for some connectivity purpose. So this is basically VANET. Now, if we want to propose any solution in the research opportunity that is available in the VANETs, it is necessary for us to understand the basic characteristics of VANET. So let's quickly go through these key characteristics. So our VANETs have a frequent network disconnections, and they have a dynamic topology. So that means to say that since our vehicles are keep on moving, our the vehicles cannot be connected to a single network for a larger time duration, because when we talk about the DSRC, the maximum area that it can cover is almost around 2 kilometers only. Therefore, since our vehicles are moving continuously and it can easily cross the 2-kilometer area, very frequently our vehicle will get disconnected from a particular network, and again it has to dynamically join to the other network. Therefore, here the network will keep on changing. That is why we will say that there is a frequent network disconnection and the dynamic topology. And this characteristic says that we do not have enough time for the connectivity, and we do not have enough time, or we cannot delay for data transmission and the reception. Therefore, everything has to be done at a faster rate, and delay cannot be tolerated over here. Next is a limited communication range. As I said, in DSRC, we are making use of a range which is a maximum of 2 kilometers. Again, this is a maximum range 2 to 3 kilometers, depending upon the vehicle density. That is because we have a very limited bandwidth of 75 megahertz, where each and every user should be provided with the service, right? So when within the available 75 megahertz, that too is not available completely for the user, because certain bandwidth is again taken back as a control channel within that control channel, the user cannot send their request and they cannot transmit the data. So only service channels are available for some communication purpose. So within that, in order to provide connectivity and in order to provide service within a shorter bandwidth, it is necessary to make sure that only the limited number of vehicles are present within that range. When it is overcrowded, nobody will get the service. So if we consider the highway, in case of highways, our DSRC range may go up to 2 or 3 kilometers, because the vehicle crowd will be minimum over there. But when it comes to the city scenario, the crowd of vehicle is too much, and hence the 2-kilometer range will also, I don't think it will work because of that crowd, depending upon the traffics. Therefore, we have to make sure that whenever these RSUs, that is fixed infrastructures, are deployed along the roadside, depending upon whether it is a highway, we can deploy those RSUs at a distance of 2 kilometers. But when it comes to the city scenario, depending upon what is the probable traffic in that particular road, we have to decide at what distance the RSUs can be deployed. So that is one of the characteristics of VANETs, that is limited communication range. Next one is the resource constraints. So here, since we are making use of OBUs, and our OBUs will have the processor that have a limited computational power. That is, since we are using these processors for a specific application only, then we might be using a processor which may not work like a supercomputer. So within the available processor, capacity of the available processor only, we have to implement our VANETs. And the second constraint is with respect to the memory. So even the available memory is also very limited. Therefore, our OBUs cannot store huge amount of data. Therefore, here we have two different constraints. One is the computational power with respect to the processor that we are using, and another is the memory constraint. So by keeping these two things in mind, it is necessary for us to build an efficient communication protocol that can effectively make use of the available computation power and also the memory of our OBU. And another resource constraint, as I said, is better or efficient utilization of the bandwidth, which is nothing but the resource management. Therefore, when we are trying to propose a solution for any research problem, we have to keep these three things in mind, and accordingly, we have to propose a solution. Now, we know what exactly is a VANET and what are the key characteristics, right? So, but why do we require VANETs? So, there are certain applications of the VANETs. The most important application of VANET is the safety application. So in safety application, the very first one is collision avoidance system. So for example, when two different roads are merging to be a single road, obviously the vehicles will be coming from both the parallel roads which are going to merge. And whenever those vehicles are connected to the VANETs, those vehicles will be sharing the information like what is the position of the vehicle, what is the speed at which it is coming, and what is the trajectory, that is in which direction it is going to move. So if that particular vehicle is broadcasting this information to all other vehicles, then other vehicles can take decision to reduce their speed if it gets to know its trajectory and the speed. So by performing by getting that particular information and taking the necessary action, it is possible that we can avoid the collision. That is the major application of VANET. Secondly, emergency vehicle notification. So if we want to be a part of VANETs, obviously we have to register our vehicles with the VANET system. Similarly, if there are some vehicles, for example, take an ambulance. When an ambulance is registered under VANET, that can be given a higher priority. So when VANETs, when the ambulance will take a higher priority in VANETs, if a particular ambulance is coming and RSU get to know that is the roadside unit get to know that a high priority vehicle is coming, then it can broadcast a message to all the vehicles stating that a high priority vehicle is coming, and these vehicles cooperatively can work together in order to give way to the ambulance. So that is nothing but emergency vehicle notification. Next one is road hazard warnings. So road hazard warnings means if an RSU get to know with the help of some other vehicle that there is a road closure ahead, or else a road accident has happened nearby, then that RSU can send the data to another RSU, and that RSU can send the data to the vehicles which are connected to that particular RSU. That so your other vehicles will get to know that there is a road closure or a road accident. Therefore, it can dynamically reroute themselves. So when they can dynamically reroute themselves, obviously congestion will also reduce, and with the help of this road hazard warnings. So that is the major application of VANET. Apart from safety application, it is also helpful for the traffic management. So how it's helpful for the traffic management? So if your RSU get to know what is the density of the vehicle in a particular area, or RSU will get to know that there is a congestion of traffic in this particular area. So when it gets to know about the congestion, it can transmit that information to another RSU, and it can send or broadcast the information to all the vehicles that are connected to the second RSU, stating that there is a congestion ahead, and so congestion warning can be given to the vehicle users. And second one is cooperative adaptive cruise control. So this adaptive cruise control, where it is possible for us to control the speed, and most of the cars are actually nowadays are making use of this facility. And the third one is electronic toll connection. So this also we have seen electronic toll connection. It is also considered to be one of the application of the VANETs. So VANETs will play a major role even in the area of infotainment and passenger comfort. So how means, as I said, it is not necessary for us to make use of our mobile data whenever we will be going through our vehicle. That internet facility can be taken from the RSU. Therefore, internet access can be easily available with the help of RSU if we are a part of VANET. And then location-based services. That means we are already seeing that application in Google that will tell us about the nearby restaurants, what are the nearby hotels, or the pharmacy, right? So those location-based services can also be integrated in VANETs. Apart from that, social networking is also possible. That is, once you are connected to the VANET, it is possible for us to communicate not only with the RSU, but also with other vehicles that are connected to the same network. So since you can communicate directly with other vehicles, we can say that social networking is also possible with the help of VANETs. Now, the last application I'm considering is environment monitoring. So environment monitoring here, we will be making use of certain sensors, and those sensors present in the vehicles will be sending the information to the RSU regarding what is the air quality in the area and what is the amount of noise pollution present in that particular area. So RSU will collectively collect this data, that is air quality and the noise pollution related data from all the vehicles in that particular area, and by aggregating this information, our RSU will send a data to the centralized system, which will be able to detect whether that is a hotspot for air pollution and the noise pollution. If it gets to know that this particular area is a hotspot for air pollution and noise pollution, then proper measures can be taken either to reduce the number of vehicles through that particular road or by some means, so that the environment monitoring can be utilized in order to reduce both air pollution and the noise pollution. So these are the just basic applications. Apart from this, many other applications are also present which have already been working upon by the various countries that I'm going to discuss in further slides. Now let us see like how the VANET implementation and what is the status of this implementation in various countries. So let us start with the United States. So in United States, there is a Department of Transportation, in short called as US DOT. It has undertaken a project called as Connected Vehicle Pilot Deployment Program. So these are the links that I have added to the slide. So if anybody wants more information on this US DOT project, they can go through this particular link. So in Connected Vehicle Pilot Deployment Program, the US has chosen 3 different cities for this project, and they are trying to implement the VANET, or they deploy the VANET project over there. So when it decided to start with this Connected Vehicle Pilot Deployment Program, they faced 3 major challenges. One is the infrastructure cost, another is the vehicle penetration rate, and the other one is standardization issues. So what is the infrastructure cost and why it is considered as one of the major challenge? As I said, if we want to implement VANET, then roadside units has to be deployed at certain distance depending upon the vehicle and the number of vehicles, right? So since it is completely new thing, deploying RSU means completely you have to contribute for designing, testing, and then deployment. So all these things will cost too much. And also if it is in the city scenario, the required number of RSUs are very more. Therefore, the infrastructure cost is considered to be one of the major challenge. And secondly, vehicle penetration rate. So as we know, our vehicles till now are not equipped with OBU. So just by deploying RSUs, it is not possible for us to completely implement the VANET. We need the vehicles that are capable of transmitting and receiving the data. That is, they should be capable of acting as a communication node. So without a vehicle having an OBU, it is not possible to deploy the entire VANET. Therefore, the next question is, how do we increase the number of vehicles with the OBUs? For that, government has to take the help of some automotive industry and ask them to manufacture their vehicle along with the OBU. Then only communication can be possible. Therefore, the second challenge lies in vehicle penetration rate. Third one is the standardization issues. So without developing a particular standard, different manufacturers cannot design, cannot go for manufacturing their vehicles with the OBU, right? So the standardization is considered to be one of the major issue, and that is the reason that is when a particular standard like DSRC or WAVE protocol has been developed in order to address the standardization issues. Even after facing these challenges, US is able to consider or deploy this particular project in 3 major cities in phase by phase mode. So in New York City, I'm considering the case study at New York City. So in New York City, they took 20 months for designing and testing. That is, what is the required infrastructure, what is the required OBU, and what is the standardization that we can use. And another 18 months they have set in order for activation and evaluation of this particular project. And finally, during this particular period, it was possible for them to perform a test case by considering 8,000 vehicles at 13 different intersections or traffic signals. So they considered 13 different traffic signals and covered 8,000 vehicles, and they tried to collect the data from those vehicles. And after collecting the data, they were able to analyze the data to understand whether this VANET project is really helpful for safety applications and for mitigating the traffic problems. So totally, they considered 14 different safety applications that not only covers lane changing, that not only covers congestion avoidance, but it also covers the pedestrian safety. So by considering such major safety issues, they were able to provide 14 solution for 14 different safety applications. And it is proved that by using this particular VANET technology, the total number of accidents were significantly reduced, and even the experience of the driver is also very good. Next, when it comes to the European countries, in European countries, we have a cooperative intelligent transportation system platform, that is CITS platform. So here different various European countries will try to come together and develop a solution that will make use of intelligent transportation system. Since these VANETs are providing the application in various areas and these vehicles are behaving in a more intelligent way, this VANET is even called as a intelligent transportation system, and that is why it has got the name intelligent transport system. So Japan also has considered 2 major pilot projects. One is advanced safety vehicle and advanced cruise assistance highway system. So after this project, considering these projects, even Japan felt that the VANET is a good initiative, and hence it is also doing some research. The same thing even with the South Korea. So for different countries, they have taken a different name for their pilot projects. So when we search with these pilot projects, we can easily get to know what is the status of these pilot projects. Similar case with the China also. So these are with different countries. Now let us consider what is the status of VANET implementation in our country, that is in India. So for the implementation of VANET in our country, we need to consider some factors that are responsible for the implementation of VANET. First thing is research and development. That is, before implementation, we know that initial research has to be done, and we have to analyze that data, and then only we have to take a decision for the implementation. Therefore, different academic institutions and research organizations are conducting the research on the VANET implementation by considering various scenarios like highway or in urban mobility. They are trying to take the data. They can capture even the real-time data, or if the database is available, they can take the data also, and they are trying to simulate the scenario, and they are trying to identify whether a communication can be possible at a faster rate, whether this dynamically changing network is possible. So all those research is still going on. And then we need certain government initiative also for the implementation, that is majorly required in standardization and the deployment of roadside unit. So government only has to take an initiative to deploy the roadside unit, because there is a finance funding associated with the deployment. And second thing is the standardization. So without standardization, no vehicle manufacturer can be able to give the required OBU. Therefore, standardization and deployment of RSU majorly depend upon the government initiatives. Next is the pilot project. Once these issues have been resolved, that is proper research is done and government is ready to take the initiative, then we can go ahead with the pilot project. So as a application of VANET, we can see certain applications right now in India that I'm going to discuss in the next slide. But still a lot of effort needs to be done if we really want to completely implement the VANET in our country. But what are the challenges that are present for the implementation? So the challenges present are diverse traffic conditions. That is, we cannot predict what exactly might be the traffic condition in which particular area, because without knowing the traffic condition, we cannot deploy the RSU. Second thing is infrastructure limitation. As I said, deploying RSU all over will take a very huge funding. So that is also considered to be one of the challenge. And another is regulatory complexity. So as I said, standardization has to be developed. So those are some of the challenges that we are facing. And here, even after these challenges and since the research is going on to find out what are the opportunity for the implementation, industries are coming forward to cooperate for the implementation of VANETs. So that is the major factors involved in VANET. Now let us see where we are right now in the implementation of VANET. So here, this is the final report that has been developed, as you can see, during March 2012. So during March 2012, a final report has been submitted stating what are the required standardizations or the regulatories that are required in order to implement, and what are the role of each of these stakeholders, what policies has to be made. So by combining all these things, a final report has been submitted in March 2012. So up to 2014, that final policy has not been approved. But after approval, say if 2014 is the date when the policy has been approved, the implementation plan as per the time limit is like this. So from the date of policy approval, 5 years are required to complete this task. And from this time up to 10 years is required for completing the task stated in this second column. Similarly for 15 years and 20 years. So these are actually how it was proposed. In the first row, we can see what are the requirements in order to implement certain applications. What are the requirements for implementing the applications? In this second row, we can see what are the applications that are supposed to be completed within a given span of time. And in the third row, we can see what are the results of implementing these applications. So basically, it is an application in the middle row, requirement for the application, and finally, what is the result of application. So now, here we can see that vehicle tracking system, data center. Okay. 1 second. Okay. So since I am running out of the time, I will skip this one. I'll go to the research opportunities. So in research opportunities, we have 5 different areas. One is the security and privacy, reliability, resource management, interoperability, and legal issues. The major research lies in security and privacy. So what are the related security and privacy issues? Coming to the security issues, it deals with the authenticity and the integrity. That is, whenever a vehicle is sending some information like congestion is ahead, an accident has occurred, then that will reach the RSU, but it should be made sure that that information is not false. It is from the authenticated person. And another challenge with respect to the integrity of the data. So integrity of the data has to be maintained to make sure that the information, whatever is sent by the authenticated person, has not been modified. So most of the research is in developing the secured communication routing protocol. Next is privacy preserving technique. That is, if we are a part of if we are a part of VANETs, we will be sharing our entire data. That is our vehicle details, what is the position of the vehicle at each and every instant of time, and the driver information, everything with the RSU. But we have to make sure that only RSU is able to access this data, and no other people connected in the network will access that data, because that is confidential data. So some privacy preserving techniques needs to be developed. Otherwise, nobody wants to be a part of VANET. Next is scalability. That is, if the number of nodes are very high, how the network will cope up so that that network can operate reliably without any disconnection. That is another research opportunity available. And the resource management, as I said, optimization of the bandwidth, and power management. Power management in the sense that amount of power that we are going to use when we are transmitting the data to the RSU, because since the range is very small, there is a possibility of interference. So our OBU has to dynamically adjust its power based upon the distance of the vehicle with the RSU. And similarly, interoperability, that is the standardization effort needs to be done, and cross-platform compatibility. That is irrespective of which manufacturer is manufacturing that particular vehicle, they should be able to be a part of VANET. Apart from that, some regulatory and legal issues are related. So there are many research opportunities that are available. And still till now, quickly I'll go in 1 minute. So here, wherever you can see only these white circles, that will say that there is no implementation from the Indian in the India. Therefore, these are the major things that we can consider. And this quarter field says that a small amount of implementation has been done. So if we can go through this slide, we can very clearly get an idea like in which area we can focus more for the research opportunities. So with this, I'll conclude that VANET is a very revolutionary technology which is capable of transforming our transportation system. So by using this or implementing this VANET, it is possible for us to create a more efficient and a safer environment with a sustainable transportation system. But still, most amount of the research is still pending, and only after that it is possible for us to implement the VANETs. Thank you. If you have any questions, we can go.
Thank you, madam. If the audience have got any questions, 1 or 2 quick questions we can take right now. The next speaker is waiting. If there are any questions, please do raise your hands. Okay. Thank you, madam. It was a very detailed. I think one question is there. Nandini, madam wants to ask a question.
Yes, sir.
It was a very good presentation.
Thank you.
Okay, you told about the ambulance, that is the vehicles, right? So if there is more number of vehicles, for example, if there is a politician vehicle or ambulance vehicle or any other important vehicle, which one your VANET will identify and which one will it be given the priority?
Yeah, yes, ma'am. Since VANET is still in the implementation stage, it has not been implemented. That is why I said that some standardization and policy issues and legal issues has to still be developed. So based upon the policy issues that they are going to develop, it is left to that centralized authority to decide which will be given a higher priority and which will be given a lower priority.
Okay, thank you, ma'am.
Yes, ma'am.
If there are no questions further, so that we can move on to the next speaker. And I would like to thank Pavitra madam for that wonderful session and elaborated information on VANET. If you have any specific queries, you can also post it onto the message. She'll be happy to answer.
Yes, sir. If anything is needed, anyone can post it.
Thank you very much, madam. Thank you.
Thank you, sir.
Good. Now we have a speaker by name Pranay Chaudhary, who is connecting us from US, Baltimore. And he's going to talk about the career opportunities for engineers in USA. A brief introduction about Pranay Chaudhary. Pranay Chaudhary was my student earlier in undergrad program. Right now, he is an EBA Executive Vice President, Chief Operating Officer, and a member of firm's Board of Directors. Pranay has more than a decade of private and public experience in construction management and inspection, highway design, access management, maintenance, and incident management. Prior to joining EBA, he was an engineer for Maryland Transportation Department, State Highway Administration, where he managed and designed transportation projects. He is principal in charge of EBA's construction management and inspection, construction material, testing, and transportation structural engineering department. Pranay holds a master's degree in civil engineering from Clemson University and a bachelor's of civil engineering degree from VTU, Dayanasagar College of Engineering. He is also a certified construction manager and a certified design building professional. He serves on the Maryland Association of Engineers Board of Directors and is a member of the Maryland Transportation Builders and Materials Association Membership Committee. He is also a graduate of the American Council of Engineering Companies Maryland Leadership Program. Good evening, Pranay, and good morning to you there.
Good morning, sir. Good evening.
Yeah, please, the floor is open now. You can
right.
discuss and you can present it.
All right. Thank you, sir. Well, good morning to you. Thank you, Dr. Kiran, for a great introduction, a very good professional introduction, and really appreciate it. Before I start, I would like to thank a few people for this opportunity. First of all, Mr. Shrikar, the Principal Secretary for Government of Karnataka, Mr. Jagdish, Commissioner, Department of Collegiate and Technical Education, Mr. Prasanna, Director, Department of Technical Education, all the principals and staff, and most importantly, the students of all the government colleges in Karnataka. And last but not the least, somebody I've known for almost 23 years of my personal and professional career, Dr. B.V. Kiran Kumar. I don't think Dr. Kiran Kumar needs an introduction. I wanted to take a few moments of your time this morning or this evening, as I must say, to give you a little bit of a guidance on what the career path for engineers in the United States is. Before I start, wanted to give you a little bit of a personal introduction on myself. I grew up in India. I came here in 2006. I'm a son of an army officer. I changed a lot of schools every 2 to 3 years. Everybody in my house, in my family, has served in the military in some way, shape, or form. And I'm the only one that has actually come here to the U.S. I'm a naturalized U.S. citizen. I was with the state Maryland Department of Transportation for 10 years. For the last 7 years, I'm in a private consulting engineering firm as one of the partners, board of directors. I'm married and I have a almost 4-year-old daughter. So that's on the personal side. Anyways, moving on. So I know a lot of you students here, they will be graduating. You guys are seniors in your 4th year of college, or you're doing your master's, and you want to decide what's the next step for me. And it all has to start with some kind of an inspiration. That is the basis, the foundation of everything we do in life. When we design or basically look towards constructing a project, we look towards a vision, a purpose, and a need. It is very important to have a vision. You need to follow your passion. You need to see what piques your interest. One of the biggest things for me was for some reason, I got drawn into highway engineering, and I would thank Dr. B.V. Kiran Kumar for that. I was never the brightest student, always a backbencher. I had 65 students in my class, and I always used to sit at the very back, so I didn't have to deal with the professors teaching. And in my 2nd year in college, I had Dr. Kiran Kumar present we had a topic, highway engineering, or basics and fundamentals of highway engineering. And that very day, pretty much my life changed. I started paying more attention. Next thing I know, I'm moving in from the back bench to the front bench, asking a lot of questions. So that was the first time that I saw or heard of a topic or a subject that really got my interest, that really got me moving. This is something that really interests me. So exploring your passion, what piques your interest, having a vision is important. Now, this is important more towards, this is directed more towards the seniors and also to the professors and the assistant professors and the staff. All students, or I recommend most students, need to have a mentor. You have a mentor that you look towards, whatever that interest may be, whatever that reason is, somebody that you are drawn towards on a professional level, somebody you connect with on a personal level, but you need to have a mentor in life. That mentor has a responsibility to guide their mentee towards a certain career path. I personally think that has helped me a lot. In the undergraduate degree program, I had Dr. B.V. Kiran Kumar as a mentor, as an unofficial mentor. We would talk, we would meet, we would always talk about things. And he gave me an opportunity to understand what are the different opportunities, gave me an ability to understand what are the different opportunities out there. And I think that's where the initiation of this whole journey started. Most importantly, chase your dreams. If you like something, you believe something, it doesn't have to be coming to the US. It has to be whatever you want to do. So you want to chase your dream. And the last but not the least, and I know it's easier said than done, do not fear failure. I know a lot of my friends that have tried for years to get a job, whether they are here in the US or whether they are back home and trying to get a visa to come here to the US. They have failed and failed until they have succeeded. And a lot of them are very successful. They're still here in the US or they're back home in India and they're doing great. So do not fear failure. Learn from them and move on. So after the inspiration, the next thing is the plan. You need to set a goal. What exactly do you want to do? Do you want to do an MS in civil engineering, transportation, traffic, construction management, whatever you want to do, you need to have a goal. Whether you want to do an MBA. Pursue a degree that interests you. One of the things that I found when I came to the US, when I was in college, in graduate school, and by the way, the grad school here is the class size is very small. So you're talking about 20, 25 students. I saw a lot of Indian students, mostly Indian students. They're looking towards changing their careers based on what jobs are available. That's not what I would recommend you. They did that, and they were the ones that they ended up not having a job at the end when everything panned out. So pursue a degree that interests you, that you really like, not because you can just somehow find a job here. So that's very important. The next step is have a plan. When do you want to start school? Now, a couple of times here, like here in the US, there are 3 sessions. There is a winter session, which starts in January. There is a fall session, which usually starts in August. And then there's a summer session that starts in May. Typically, the Indian students come in the winter session, and a lot of them come in the fall session. When do you want to take the GRE or the GMAT? What colleges are you aiming for? There is a lot of information available online. You need to be very careful of what websites you visit to gather that information. Now, with the evolution of internet and a lot of stuff is being reviewed, and it's a lot more easily available now than it used to be 17, 18 years ago when I was trying to come here. So that's something that you want to do, is you want to do your research. You want to see what colleges you're aiming for. You want to go to colleges. When you look for college degrees, or say an MS in civil or transportation, you need to look at what are the good schools for MS in civil engineering. Some of the things I can name you for: University of California, Berkeley, Stanford. So those are the top schools. So you need to look at the top 10, 15 schools. Don't be shy. If you don't get into the top 10 schools, it's fine. It's not the end of the world. It's, I did not go to the top 10 school. I did just fine. The next thing is always have a backup plan, plan B. I cannot tell you all my life. I saw my dad in uniform. He retired as a colonel in 2008. My plan was, and Dr. Kiran Kumar can attest to that, was to graduate and join the military. That never worked out. And that's when I went to plan B. And the plan B was, all right, well, I like something and I want to pursue that. And that is further career studies. So if you have a plan A, make sure you have a plan B as well, because that is important. Next thing I would like to talk about is the research online. When I started researching, I was researching a lot about what the colleges are, the opportunities are. A good friend of mine was here at University of Miami, who went to Dhanansagar College with me. So I connected with him. Back then, they used to have a social media platform called Orkut. I don't even know if it exists anymore or not, but I got there and there were some forums. I wouldn't recommend going into a social media platform, but that's what I knew back then, and it kind of worked out for me. But anyways, the bottom line is you need to do your research. You need to know what websites you're looking at. Are those websites legit? And you need to grow your network. And most importantly, see if you can find somebody who's doing a career, has a career or doing a degree in the US very recently. The last thing is resource use. The US Embassy site is a place where you can find a lot of information. They also tell you how to stay away from scammers. Find a legitimate coaching institute. I went to Princeton Review. I don't even know if Princeton Review exists anymore or not. I went to Princeton Review. What Princeton Review did is so you can find a lot of information, a lot of books on GRE and all that. But what Princeton Review did is it told me how to take the exam. And that's important. It's not about studying for the exam, it's how to take the exam. What is the standard of test taking? Stay away from fake consultancies. And also look up the Indian Students Association website for each college and start talking to some of those people. They have time and they'll respond. Next slide, sir. The journey. Plan for your trip in advance. Be smart when you pack for your trip. And those are some of the things you will find out on the Indian Students Association website. There's a lot of information when you finally get into a college. Get to the US a few weeks ago before college starts. I think your I-90, which still I believe exists, allows you to come to the US a month before. Try to get here a month before. Because you need to get a job. If you don't have a graduate research assistantship job or a graduate teaching assistantship job, then you need to find a campus job that you can work 20 hours a week. So try to get here a little bit earlier because all those jobs are gone. Use the Indian Students Association resources website. Also, there's a graduate admissions office. So get all the information from them. That's how I plan for my trip. Please go ahead, sir. Next slide. Okay. So the stay. I was lucky to find a graduate research assistantship job, a graduate teaching assistantship job. So I was able to fund my education. The GRA and GTA pays for your tuition. They also pay for your health insurance, a part of it. They also give you a basic wage based on what the research is to help you sustain yourself. So that's a very lucrative position. Typically, these things have to be requested for when you apply to those colleges. Understand the culture when you're here. I got out of the shell and I interacted with a lot of American friends. I made friends with them. I mean, it's not that I was not friends with my Indian friends. I had a lot of Indian friends and a lot of American friends. So that helped me to understand the culture, helped me to understand what's going on, how to live here in this country. Work on your communication skills, very important. Reading and writing, how you speak, how you talk, how you interact. I said, make friends outside of the Indian community. Use resources available to you as a student. You're going to find a lot of resources here in US universities, a lot of it, a lot of events going on, a lot of, stuff going on in college, a lot of things going on, a lot of fun activities, a lot of technical sessions. Use those resources, get involved, go out, work hard, but play hard as well. Take time off on the weekends, say Sunday, enjoy something you like to do, go for a hike, go play a sport, go try, a restaurant, whatever you want to do, but make sure you spend some time to take care of yourself and, enjoy. Next slide, please. So the uncertainty, there is uncertainty, a lot of uncertainty. The uncertainties have increased. I try to stay away from politics, but since Mr. Trump was there, things have gotten a little bit hard with regards to foreigners coming here. It's mostly the Indian and Chinese students because a lot of them, they're the ones that are the most amount of population. So there are visa and OPT uncertainties. One thing I will suggest to you guys, when I was going for my student visa, the first thing that the counselor officer, who was an American guy, he asked me, do you have a backlog? And there were 9 people ahead of me, and I believe all of them had some kind of a backlog. I believe a backlog was back then, I don't know how it is now, was you have to pass that one exam at one shot, or that's a backlog. And they exactly know how to read your transcript. And I'm talking about these American guys. They're not Indian people. They're the final decision maker is a consular officer who's an American US citizen. And he asked me, do you have a backlog? And I said, no, sir. And he said, give me a copy of all your transcripts. And he did. And he said, give me your passport. Have fun in the US. So that is important. Try not to have a backlog. That's how it was back then. I'm pretty sure not much has changed. They want the best of the best there. And they want to make sure that those guys come in, or gals. There's a lot of jobs uncertainties. Be aware of that. There is no guarantee you come here, you'll absolutely find a job. But there are a lot of jobs. When I graduated in 2000, I'll give you a little bit of a story. When I graduated in 2008, December, right then in 2008, I would say July, August, the economy collapsed. It was a housing issue. A lot of these, basically what happened is the banks were giving out loans like crazy, and there were a lot of defaults, and basically the banks went down on Wall Street. That very year, almost a year ago, I went to the Clemson Career Fair, and I had a year to graduate. I get into the bus, the local transit bus, and it was full with Indian students, mostly, and they were all making fun of me. They were like, look at that smart, too smart of a guy. He thinks that he's smart. He's got one more year to go to graduate. And I didn't pay attention to nobody. I had a stack of resumes. I had a suit, a nice tie, woke up, looked good. I went to that career fair and gave my resume to every single civil engineering person there that had put a stall, and they were looking for civil engineers. And I came out with a job. And that's it. That changed my life. That was a government job with the Maryland Department of Transportation, starting as a transportation engineer with a offer letter and a hiring bonus. The reason I got it, because I didn't listen to anybody. I went with my gut. So every time I've gone with my gut, and I'll say this to all you students, go with your gut. You think something is right, go for it, do it. Looking for jobs, resources through campus placement office. There's a lot of resources at the campus placement office. There were a lot of seniors that had graduated before me, so I was in touch with them as well. Just because I got one job, I was not complacent. I was looking for multiple offers, and I actually ended up getting one more offer. So I graduated in December of 2008 when the economy collapsed, when the citizens here in this country did not have a job. I had a job. I came here and started my career back then in 2008, December, in Baltimore in the highway design division as transportation engineer. So next thing. So the first break, you're all going to get your first break. I hope you do. But when you do, make sure you go for a job that is aligned with your degree and interest. I told you the story about when students started jumping ship and going to doing an MS in construction management. And I was like, why? You came here to do MS in transportation, in traffic. Why are you going? Well, because there are more jobs. I don't agree with that. And I'll be honest with you, a lot of them never ended up finding a job. Go with something that interests you, because something that interests you is something that you will excel in. Don't be picky about location. I have a friend of mine. He went to Nebraska for a job. He actually went to the Anand Sagar. He went to Arizona State. He ended up working at a meat processing plant in Nebraska. And he's an industrial engineer. I mean, Nebraska is almost Midwest, middle of nowhere where he was. And he did great. He works for Amazon. He's in senior leadership now in Seattle, Washington. So don't be too picky about location. You will be welcomed here. People here are nice. They're welcoming. You just got to play by the rules. And the third one, this is very important. I see a lot of people, actually people that have lived here almost 18 years, like me, are still on a green card or still on a visa and don't know their status. Why? Because they went with an employer who did not give them the assurance that they will file for a visa and potentially a green card. And OPT is only valid for 3 years. After that, you have to have an H1. And after 3 consecutive renewals of an H1, which is total of 9 years, you need to pass a certain step of your green card to maintain your H1. Otherwise, you have to leave the country. And once you leave the country, coming back here is not that easy. So those are the things that you need to look into, and you need to be very cognizant and very careful that when you find an employer, make sure you're very clear and they're very clear of your visa status, and you need to get some kind of a written assurance, not verbal, a written assurance that they will file for your H1 and potentially a green card if you do plan to stay here. Well, last but not the least, when you do start the job, don't be afraid to ask questions and learn. One thing is, when you do ask questions, and this is from my personal experience, write it down. Try not to ask the same questions over and over again. But when you do ask questions, you learn from them, and you remember, and you move on, and you will do very well. The future. Don't stress too much about the future. My dad has always told me when I didn't get into the military, I took the SSB a couple of times. Unfortunately, I was not successful. My dad said something to me that still resonated till today. He told me, he said, Pranoy, what is in your destiny, nobody can take away from you. And what's not in your destiny, nobody can give to you. So don't stress about the future. Don't worry about it. It's going to play out. Take charge of things that are in your control. One of the things I did is I had a lot of fun in undergraduate. I'll be honest with you. I mean, I got into trouble. Dr. Kiran Kumar probably saved me a bunch of times. But I got my act together in MS. I studied. I went to college. I woke up at 7:30. I got breakfast. I went to college. I was there till 2:30, 3 o'clock. I came home. I took a nap, and I studied from 5 till 10 o'clock at night. Every day, almost 5 to 6 days a week. I cannot believe I did that for 2 years. And that was because I knew this is my one and only shot in this country to get a job and get things going. Because if I follow the same protocol I did in my undergrads, I'd probably be shipped back home. And that worked out. So take charge of things that are in your control. Very important. When you start your job, get the credentials that you want to get to excel in your career, a certification core, your licensure, whatever you want to do. Make smart financial decisions. You know, you don't want to live eating Maggi every night or ramen noodles, but you know, you want to enjoy it, but you also don't want to go out and, you know, take a whole lot of debt. It's very easy here to buy things on credit. So make financial decisions, keep some money in reserve. You will need it. Do not neglect your personal life. You know, if you want to start a family, meet somebody, whatever you want to do, you know, you want to get into something, a hobby or anything, do not neglect your personal life. That's very important. Next slide. Well, most importantly, have fun and enjoy the journey. I've really enjoyed the time I've been here. The plan was always, and Dr. Kiran Kumar with our test, was to complete my engineering and go back. But one thing led to another, and here I am. It's been 18 years now, a couple of years, almost half my life I've been here. But really have fun and enjoy the journey. And you know, that's very important. I think those are the things that we miss out on a lot. So that's all I have. It's not very detailed, but try to share some of the things. One of the things I'll tell you, there is no pocketbook, no checklist to success. If you can take a couple of things that I talked to you about today, I would be happy. And you know, when you all make it here, I'd love to connect with you. So I will leave it up to the forum for any questions.
Thank you, Pranay. It was indeed a fantastic presentation, and the entire thing came in front of our eyes. I think there is couple of questions. So one
right.
By Professor Suresh. I think we'll unmute Suresh. Madam, please unmute Suresh. Professor Suresh. Sir, Suresh, sir. Am I audible, sir? Suresh? Yeah. Please go ahead, sir.
Sir, good evening, Pranay.
Good evening, sir. Yes, sir.
Yeah, so the presentation was highly informative and highly inspiring. So you told something about backlogs. Can you please elaborate what is that backlog mean?
Yes, I would love to. So I don't know how. So I went to Dayanand Sagar College. I did not go to a government school. So what used to happen back then, and I think Dr. Kiran Kumar will be able to assist, we used to call it something called a backlog. Basically, if you take, you have
No, is it with something like courses that underwent during your UG courses? That is the backlog?
Yes.
Okay. So because no, you told that when you are interacting with some officer in the US, so that there it was something like backlog was inquired.
Yes, they are very familiar with the technical education system in India. So my counselor office that I got assigned, because back then Hyderabad, my parents were in Hyderabad. My dad retired from Hyderabad, so they're there. Back then Hyderabad did not have an embassy, so I had to go to Chennai to get a visa. And the counselor officer asked me, "Did you get a backlog when you were in your undergrad?" And he knew exactly what that term was, which is a very technical term, which basically means if you don't pass one of your subjects in one shot, you take it in the next semester. And I said, no. And your transcripts reflect that. And everybody that had a backlog did not get a visa, at least that day. So that was something that I kind of knew that, hey, that helped me out.
So there are means no much opportunities for the students who have something like backlogs there.
Again, here's the thing, Dr. Suresh. I'm not saying that that's the truth. I'm saying that's what it was 16, 18 years ago.
Okay.
I'm sure every counselor officer is different. But if you don't have one, try not to get one.
Okay. Thank you so much.
Absolutely.
Thank you, Pranay. Thank you. If there are any other questions from the audience side, we had somebody raising the hand, a student earlier. Chaya was trying to pose some question. If it is not there, Chaya is there? I think she is not there, Pranay. Anyway, thank you, Pranay. It was indeed a splendid evening that we spent with you, and in your busy schedule, you took time to.
No, absolutely not. I'm here, and Dr. Kiran, wanted to again thank you for the opportunity. If there are, any questions, if they can send them over to you, and maybe you can email it to me, and I'll love to take some time off and respond to them.
Nice of you. Yes, definitely. I would like to do that. Now we are at the end of this technical session, AROHAN Series 9. It's my prime duty to thank all the presenters today for coming down to this platform, taking out time and giving us the insight about the subjects that they have learned, and as well as to the students, guiding them for taking the right career path. With this session coming to an end, it is my prime duty to thank all the participants, as well as the students and the presenters, as well as the department, which has given a wonderful platform for us to interact and understand what each of us are doing it. So with this small note and thinking that we'll have connect again another 15 days with more interesting topics, I would like to sign off today's date. Thank you one and all who have been present and making this particular session.
Sir, Kiran sir, thank you for the opportunity, sir. Thank you so much.
Thank you, sir. Thank you, Suresh sir. Thank you. So with this, we end this session and we sign off, and thank each and everyone who participated and contributed to this session of AROHAN 9 Series 9. Thank you one and all.